over the whole internet. So the Colorado University people in particular, they collected their data set. They had traffic logs of connections that people made out of their exit relay. And then they went to an academic workshop and they said, so we really want to anonymize this and then publish it so that other people can use our data set to do research on. But the problem with that is, so the goal of Tor is, if you don't have traffic at both ends of the circuit, if you can't see Alice's side and Bob's side, then you can't win, because you can never realize that this Alice is talking to this Bob. And the people at Colorado were thinking, all we have is the second half. All we have is the side on Bob. So publishing this can't hurt anything, right? Nobody's ever going to be able to match up an Alice because all we have is the second half of the traffic. Imagine there are 10 research groups out there, and 5 of them log their exit relays for a while, and 5 of them log their entry relays for a while, and they all use that same logic. They all say, well, I only have half the circuit, so there's no problem with me publishing this. That might get real bad. So we convinced them that they shouldn't publish it, but it would be great to have some data sets out there. On the other hand, it's illegal to collect them, depending on which lawyers you talk to. So I don't know what the right balance there is. And then the more fundamental questions: who runs the relays? Last year at CCC, I was talking to the WikiLeaks people, and they said, I know for sure that there's a Tor exit relay in China that's run by the Chinese government that's watching everything. How do they know that? I don't know. Maybe they're just making it up. Maybe they do know it. Probably there are some bad Tor exit relays out there. Probably there are some that are watching the traffic and trying to make use of it somehow. At the very beginning, you had to actually send me mail and say, hey, Roger, I want to run a relay. I'm that guy you met at the conference. You convinced me. Here it is. I set it up. And then I would go look at it and see if it's reachable and manually add it to the list. That scaled even less well than I thought it would. So after about 20 relays, I started getting mail from people in Russia and people in various places in Africa and Europe and South America. And if the goal of the Tor network is to have as diverse a set of relays as we can have, then do I say no to these people? Do I say, no, we only want Tor relays at Harvard and MIT, because that's where I know people? That can't provide a very stable community, a very stable network. We need a bunch of relays all over the world in order to decrease the chance that there's an attacker who can see the beginning and the end of your circuit. So at that point, you have to let everybody sign up. So now if you want to run a Tor exit relay, just go configure it and start it, and you'll sign up, and that's that. And we are very open. We have a lot of relays. But then we have the question of how do we design a system so that we can tolerate some small fraction of relays that are trying to track people down. And then it gets even more exciting. What if you end up exiting through somebody in Ohio, for example, who's running Windows on his exit relay, and he's running the latest antivirus gadget on it, so that it intercepts all incoming web pages, and it looks through them, and it finds bad JavaScript, and it takes it out, and so on. So that means that somebody in Germany using Tor is actually getting different results because he's popping out of this Windows system that's changing the pages he gets back. Maybe that's good in most cases. I mean, nobody wants bad JavaScript, right? If somebody takes it out, that's good. On the other hand, there's a group at CMU that studies phishing, and they get the latest phishing websites from CERT on the condition that they only look at them through Tor, because otherwise they'll be revealing to the phishing websites that CERT knows about them. So at that point, they actually do want to see the page that they're seeing. We've talked to the Stop Badware group at Harvard, and we've been talking to SiteAdvisor. I guess they're called McAfee SiteAdvisor now. And they really want to actually look at the internet from various places so that nobody can say, oh, it's the Harvard Stop Badware group that's looking at my page. I'm going to give them a good-looking page, and I'm not going to try to infect them. So we actually do want to let people see the pages as they should be. What if your exit relay is in China and you're trying to read BBC? So now this nice person in Ohio is just, reading the internet through Tor, and he tries to go to BBC, and the Chinese government censors him. That's not actually what we had in mind. And it actually gets even more scary than that. What if you're happen to pop out of an exit node in China, and it's doing an SSL man-in-the-middle attack on you. We actually encountered this. We were, searching through the exit nodes, trying to figure out which ones were doing bad things, and there was an exit relay that was just taking off the SSL certificate and putting on its own self-signed certificate. So you go to eBay or PayPal or whatever, and it gets to read all your encrypted traffic. And we thought, oh my God, there's somebody attacking the Tor network. And then we looked at it some more, and we realized that actually it was the ISP for that guy just attacking all of its customers, because Chinese ISPs do that. So we managed to find a Chinese ISP attacking its customers, and some Tor user in Ohio got attacked by the Chinese government because he happened to pop out of some Chinese exit node that was attacking. What if China gets a copy of a root certificate? Now they can swap out the SSL certificates and put in valid ones, and then they can read everything that goes across their network. That's kind of a scary thought. A couple of years ago, we had another question to try to figure out how we should balance these things. What happens if 10 really fast, really stable Tor relays show up, all from 149.9.something.something? And a lot of people looked at that and said, hey, you're being attacked. These are obviously somebody trying to run a large enough fraction of the Tor network that he can see a lot of traffic. So we said, okay, we should investigate who they are. So we did a whois on their addresses, and it's a little place right outside of Washington, D.C., which made a couple of the paranoid people a little bit concerned. And so then we looked it up, and it was a PSINet address. So we got one of our friends at Cambridge University to give a call to the PSINet people, and he called the Network Operations Center and said, hey, who runs this IP address? We're curious. And the PSINet operations people said, oh, wow, you're right. We don't have that in our database anywhere. I guess that is ours. Good point. Which didn't really help the paranoid people. So we actually tracked it a little bit farther back, and we actually found some people who are part of the security hacker community, and they were just trying to help out. They had an interesting business model, which is we sell co-location service, and it's cheaper if you run an exit relay on the stuff that you buy from us. We'll give you a discount if you run an exit relay. And it hadn't occurred to them that running an exit relay on an IP address just next to itself, it wasn't actually the best way to provide good anonymity for the Tor network, because they were just adding them all to the same /16 network. So the fix for that, in that case at least, is we actually, now the Tor clients look at the different IP addresses and say, I'm never going to use more than one relay from a given /16 in my circuit. So there are a bunch of relays from 149.9, but we'll use at most one of them when we're connecting. So that means we're never going to have one at the beginning of the circuit and at the end of the circuit. Could you run a bunch of different relays with different IP addresses? Sure. There's a fellow at Georgia Tech who studies botnets, and every time I talk to him, he says, with one command, I can sign up 100,000 Tor exit relays all around the world. What would happen if I do that? And my answer is always, please don't. But I'd like to have a better answer than that. And I don't have a better answer than that. So we had another fix, which is no more than 2 relays per IP address. So you at least have to have a bunch of different IP addresses on the network before you can run a lot of different relays and get believed. But what about different autonomous systems? What about different internet exchanges? What about different countries? How do you measure these things? Because looking at the /16 is not good enough. There are plenty of ISPs that have a lot of different /16s all in the same building. So I don't have a good answer for how the client should automatically recognize that these 2 relays are nearby each other physically or administratively or network-wise or something like that. And I want that ideally to be something that's very efficient, that Alice can compute on her own and predict where her path is going to go for any given selection of relays. Okay, and there are a couple of other issues we can talk about. Yes? Apparently the sound is not going through the stream. Can anybody here do anything about that? Yes, I see a hand and a nod. Okay. Sounds good. Keep up the good work. Okay, so there are some other attacks we need to worry about. One of the big ones is the JavaScript refresh attack. So here's the way it works. You go to a website using Tor, and it gives you a page that refreshes every 60 seconds. And so it refreshes over Tor, you're fine, you're anonymous, and then you use Tor button to turn off Tor. So now you're not proxying from your browser through Tor anymore. 60 seconds later, the page reloads again, not using Tor, and then you lose because you just told them your IP address. So there are a bunch more subtle versions of this. You don't need JavaScript. You can do it with CSS. You can do it with some other tags. And then there are cookies and history. And whenever I go to a website, I tell them how many pixels by how many pixels my browser window is. I think in IE, they just tell it by default. And in Firefox, you can use JavaScript to look it up. And then there's which language I prefer to speak and exactly which version of Firefox I have. And here are some authentication things. And most of these are problems when you toggle Tor on and off. So now I'm using Tor, and I visit this page, and then I turn Tor off. And the next page can go rummage through my history and look at all the pages I've seen before. So the new version of Tor button that Mike Perry put out in July of this year tries to deal with a lot of these things. It actually blocks lookups for history, it blocks cookies, it clears the cache every time you switch back and forth, it makes sure to round the size of your window up to a certain amount. So it tries to tackle most of these. And so we used to say, we recommend Tor button with Tor, and now really it's the only option. You better use Firefox. None of the other browsers have something like Tor button, and you'd better use Tor button. And there are some other bugs in Firefox that we're still working on. One of the big ones is if the website you go to tries hard enough, it can figure out what your time zone is. Because we can't figure out a way to actually hook the date and time zone stuff inside Firefox in a way that the website can't figure them out. And then another fun one, if you have any client-side SSL certificates, most people don't, then your browser will happily send them to whatever website claims to look a little bit like the certificate. So you can start giving away personal information without realizing you're doing that. And then the other fun one in Firefox 2, when you're doing an SSL handshake, when you're doing a TLS connection, part of the spec says write the current time in this field when you're communicating back and forth. And the Firefox people looked at that and said, we're going to put uptime. We're going to put your computer's uptime in the time field. What the heck? But they did it, and then we went to them and said, shouldn't you fix this? And they said, it takes so much CPU time to figure out what time it is. It's just easier to put the uptime there. And we said, but it's a privacy problem. You should fix it. And they said, there are lots of privacy problems. Why should we fix this one? And that's not good. So I think that they're doing better in Firefox 3, so I guess we just wait. And tomorrow they'll put out another version of Firefox 2, and then maybe they'll end of life it. And then some other problems. A lot of applications are bad at obeying their proxy settings. So PDF is a good example of this. The way it works is you go and you click on a PDF URL, and your browser says, oh, I have a plugin for that. I'll just hand that URL to the PDF plugin. And the PDF plugin gets the URL and says, oh, a PDF, I think I'll load it. And it goes to the network and fetches it. And it's never heard of proxy settings. Why would it use a proxy setting? And that means that if you click on a PDF when you're using Tor, then you just bypass Tor and you go directly to the site. That isn't actually what we had in mind. And then there are a bunch of other plugins. Flash is a good one. Flash can just look up your IP address. It gets to look around locally. It can load files. It can do whatever it wants to do. So Tor is doing its job. Tor is anonymously fetching the Flash applet from the website. Tor is anonymously sending back your IP address. Tor is doing what it's supposed to do. But that isn't actually what people had in mind. So the approach that Tor button has right now is no plugins. We don't let you use Flash. We don't let you use Java. We don't let you use all the rest of the stuff. And then there are some other tricky ones. Apparently, if you put enough backslashes in front of something in Windows, then it turns into a network lookup. That's not good. So there are a couple of solutions here. One of them, and